Now we are going to discuss how to find a quadratic polynomial if sum and product is of the zeros is given. S, we denote S by sum of zeros, which is, we know, we have done that alpha plus beta, and product is alpha beta, which is product of zeros. It is given by, it can be done by two methods. One is the simple one, that fx is equal to any quadratic polynomial if sum and product is given by k. S and p is given by S and p, then the polynomial is given by k x square minus sx plus p, where s is the sum of the zeros and p is the product of zeros. Let's try to understand with the help of example. Like there's, if they say that form a quadratic polynomial if sum of zeros is 2 and product of zeros is 3, so directly you can put the value that the quadratic polynomial is given by k x square minus 2x plus 3, where k is constant. That its value I'll let you know afterwards. And the other method is ax square plus bx plus c. Let's consider the same example, that if sum is 2 and product is 3. Sum is 2, product is 3. We know sum is alpha plus beta, but it is given 2 here. And if we compare it with minus b upon a, then b is minus 2 and a is 1. Similarly, product is given alpha beta, and which is c upon a, but product is here, we have given it is 3. So that means it is 3, c upon a. If we compare, c is 3 and a is 1. Now we see that a is 1, that means our values are correct. These are same. So now the quadratic polynomial is given by ax square plus bx plus c. Let's put the value. A is 1, b is minus 2 and c is 3. So our given quadratic polynomial is x square minus 2x plus 3. In this k is not required, because here we are directly finding the values of b and a and c and a from the our given formula alpha plus beta alpha beta. Here k is not required, but here we are directly using the values s and p, therefore k is required here. Why k is required? Let's try to understand with the help of one more example. If s is given 1 by 4, now in case of fraction it is required. If s is given 1 by 4, product is given minus 1. Required quadratic polynomial is given by k x square minus sx plus p, x square minus 1 by 4x minus 1. To avoid the fraction, if we take the LCM here, you will get 4x square minus x minus 4k. Here, so as to avoid the denominator, here we can consider the value of k as 4. So our required polynomial is 4x square minus x minus 4. In such cases, we can apply this k formula. So you can choose either of the methods, whether this one or this one, it's all up to you. Is it clear to everyone? Now let's try to find out the division algorithm for polynomials. Division algorithm for polynomials, this is what we have discussed earlier also, that we know that dividend is equal to divisor into quotient plus remainder. Now what actually is division algorithm? That if px and gx are two polynomials with gx is not equal to 0, where gx is divisor, that means divisor should not be 0, then we can find polynomials qx and rx such that px is equal to gx plus qx plus rx, where px is dividend, qx is divisor and quotient is qx and remainder is rx, where rx can be 0 also, that means remainder can be 0 also, or degree of, we know that degree of remainder should be always less than degree of divisor. Let's try to understand this with the help of example. That divide, this we have done in 9th class also. Divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square. First of all, we have to arrange the terms in the standard form. That means that in the increasing or decreasing order of exponents, like minus x cube plus 3x square minus 3x plus 5 minus x square plus x minus 1. And you know the division, how to divide them. As degree of remainder is less than degree of divisor, degree of remainder is here 0 and degree of divisor is 2. So we have to stop the division here. So quotient is x minus 2, remainder is 3. Now they are saying that verify the division algorithm. So dividend is equal to divisor into quotient plus r. You have to put the value of divisor and quotient and remainder, multiply both of them, then you will get your desired result. So here it is verified. Now based on this division algorithm, you have to do your 2.3 question number 1 and question number 2. Next, rest will be explained in the next video. Thank you.